Hello and welcome to Office Hours. I'm Greg Yatman. Joining me today, as always, is Mehmet Yavuz, our CTO and co-founder at Celona. Also, we have Srini back. So you know by the fact that if you watched last episode, if Srini's here, we're going to go into some deep territory. So we've spoken around system identifiers and CBRS in the past. One of the things that came up after our last recording was we were talking about devices. Now, being on the band 48 with your CBRS device, I mean, how does that work when you're moving from these macro networks to the CBRS network and vice versa? So with that, I thought it was a good topic. We should talk. Srini, Mehmet, let's dive in.
So basically, this all operation depends on the device categories, and we put those into two different device categories. One is the devices provided by the enterprise for their workforce, employees, or maybe even IoT devices. And the other category is the devices that customers or visitors bring with them as they walk into an enterprise, right? And we call that MNO provided devices. So the solutions are a bit different for these two categories. Just a quick example for the employees, for example, the enterprise IT can give them iPhone 11s or iPhone SEs with dual SIM cards, and one SIM card may belong to the operator. The other SIM card may belong to the enterprise. So these devices can basically have dual SIMs in it, and they can handle roaming as they come into the enterprise network or as they leave the enterprise network. So going into some more details of it, given Srini is with us, I'll just maybe give Srini an opportunity to go deeper.
Good afternoon, Mehmet and Greg. Good to join you guys on this. And as such, I think we are looking at the types of subscriptions that can be defined onto the device and the RF capability of the device. This is going to define what mobility and how to find a CBRS network is going to be. The subscription itself can be an MNO subscription or an enterprise subscription. The device can have a single or two of them. And a lot of it depends on whether it's a locked device or an unlocked device. And locked device typically requires the MNO to push the credentials onto the device. Unlocked, an enterprise can actually add an additional credential onto the system. Now, how does it find a CBRS network? It runs through periodic scans, or it can even get sophisticated and based on UE implementation, where it can do a geofence scan, knowing the type of systems and the location of the systems where it wants to find it. Now, it also depends on the type of RF capability which is there. The devices are typically single receive, single transmit, or a dual receive, single transmit, or a dual receive and dual transmit. Based on the type of device, there may be tunaways needed to find the CBRS network. If tunaway is required, then you're not available on the current system where it's currently associated with. So it essentially needs a little bit of a break in traffic or association process, which typically tends to be in idle mode where the device tries to find a CBRS network. Now, it performs these periodic or geofence scans, and it finds a valid system to go onto the CBRS network.
Okay, so let me stop you right there. Valid system. I think we were broaching this topic with system identifiers previously. Is that the right track, or is it something completely different this time?
Oh, you nailed it perfectly, Greg. It's exactly correct. These are these identifiers we talked about before. It's PLMN IDs, CSG ID, which is Close Subscriber Group ID, Participating Service Provider IDs, PSP IDs, or Tracking Area Codes-based information. Now, typically what you're going to see in the market is PLMN-based systems which are there. They are not PLMN ID-based system selection, which has been addressed by the 3GPP system scans. CSG and PSP-based methods, Close Subscriber Group and Participating Service Provider-based methods, these are really not very commercially available on the existing devices. So this leaves us with only PLMN ID-based system selection to find the networks, which implies you're using the SHNI, which has been a shared HNI, which has been defined by 3GPP, and essentially using the CBRS mechanism of using 310010 as the MCC MNC to find CBRS networks as you're finding the system. Multiple CBRS networks can be associated with the same SHNI, but there are other identifiers that we talked about, the tracking area code, which can be used to isolate specific systems. Now, let's assume the device finds a valid system. Now, we've identified what is a valid system. Now, based on the valid system where it's been authenticated, there's something called as an MRU, which is retained in the device. MRU is most recently used system. And as part of that, it maintains not only the frequency, it also maintains the geofence information and the type of credential and what services are available on that system. So the UE is capable of knowing and recognizing a previously associated system and finding that particular system.
All right, so let's talk about the behaviors of these voice and data transitions. And what are they, and how does that work?
Yeah, I mean, again, at a high level, you can think about it this way, right? For all the data services, device switches to the CBRS network as soon as it detects it. So that's some baseline behavior, somewhat similar to Wi-Fi today in terms of the behavior. Of course, the quality and the predictability is much higher. Now, the voice is a little bit different. In the case of voice, typically the enterprise CBRS network will not have the so-called IMS service and so forth. So there is an additional step in terms of how do you handle the voice services such as VoLTE. And Srini, why don't you comment on that a little bit more?
Yeah, like Mehmet pointed out, the CBRS network tends to be data-centric, and which implies a lot of the voice capabilities for enterprise networks. It's either PBX fixed terminal-based voice or over-the-top voice, but any of them numerously available applications that are out there. But note that CBRS solution, as from a Celona perspective, is fully optimized for carrying both voice and data. The scheduler from a RAN perspective is fully optimized for voice, both from a power and from a QoS operations perspective. It's a fully optimized kind of solution that we have. And it can actually fully camp using the RAN network for voice service support there. Now, typically what you're going to see is you're going to be either in an MNO coverage or not in an MNO coverage. We did talk about dual SIM, dual standby, DSDS type of devices where the voice services typically retain on the MNO networks. Now, the data service can be offloaded independent of the voice onto the CBRS platform. With that, what happens is your voice tends to remain on the MNO network, and you operate your voice services completely on the MNO network without any transition to CBRS. The problem happens only when there is no MNO footprint and you need to transition the voice services onto the CBRS platform. When that happens, what you're going to have is you're going to support VoLTE directly on the CBRS network, because this is voice optimized for VoLTE that we are going to support from Celona solution. But there is also an additional method by which you can support it, something called as Wi-Fi calling. Wi-Fi calling doesn't mean that it is supported only on a Wi-Fi system. You typically are going to see a system by which you have a local breakout, which is obtained from Wi-Fi, and you're connecting a secure tunnel into the MNO core for IMS PDN connectivity services for voice services there. Now, the same local breakout can be provided through an internet PDN, which is supported on a CBRS platform with another independent subscription, and you're using a CBRS subscription to support that internet PDN connectivity, while at the same time, you're supporting voice as a secure tunnel on top of the internet PDN connection on CBRS, tunneling directly into the MNO core.
I hope that wasn't too confusing, but I mean, bottom line is that we provide that infra solution, right, for the enterprise. So that infra solution is the complete wireless and the core solution. It brings all the benefits of the LTE and the 5G technology. And we have the quality of service for voice applications and other applications that's ensured. And then we're also working with a bunch of partners on the device side, on the backend side, and also a bunch of operators to really enable this seamless transition between the microcellular network and the CBRS LTE/5G network. With that, Greg, back to you.
All right. So MRU, WFC, VoLTE, MNO, all these topics, they seem confusing to me. However, you're starting to illuminate my world. And the best part about it is that we have folks like both of you that are able to make the complicated simple. So thank you for doing it here on this program. Thank you for sharing with our followers, our listeners. And for those who are listening, feel free to like, subscribe, share, and come back because we have much, much more on the way. Until then, we'll talk to you soon.